All right, this lesson is section 1.6. It's on linear inequalities. We've got two objectives. It's not too terribly long. Okay, so our first objective, being able to solve and graph these things that are called linear inequalities. We got linear and compound inequalities. Okay, and so the second one is we're going to be able to use the notation that's involved in writing your answer. So describe the solution set of inequality using set builder and this thing called interval notation. So the first objective, I think you probably maybe did a little bit of this, definitely in Algebra 1, and maybe a little bit whenever you talked about triangle inequalities in geometry. But number 2 is going to be completely new to you, but that's okay. It's easy. It's just notation. Okay. So, and then you can see our assignment here, and I wrote in there that I want you to get practice using both. Like your book will probably only give one form. It might give it only in set builder or only in interval, but I want you to practice it in both. Okay, and then you have that set of challenge problems. No, they're not optional. Yeah, you have to do them. Okay. So, first objective, you'll be able to solve linear and compound inequalities. So I picked this picture because maybe you've seen some guy like this. Maybe this guy is you whenever you look in the mirror, or a girl, and one of your ears is bigger than the other one or something, right? It's very easy to see that there's some sort of inequality going on there. One thing is bigger than the other one. And like, my sideburns, I sometimes have trouble getting those even, so like whenever you look at me tomorrow morning, that's probably what you're gonna look at me, and I'll know that you're looking to see if my sideburns are equal or not. Anyway, so inequalities. So the word linear, first of all, so linear inequalities, let's take that part at a time. The word linear in math refers to one of two things. It could refer to the root of that, which is just line. So it could mean that the graph is a line. Linear, it's a line. Okay, easy to understand. The other thing, especially in algebra, what linear means is that if you have variables raised to powers, the highest power that you can have is 1, right? So the highest power in any variable is 1. That's also what the word linear means, okay? Then the inequality part, well, it has equal as the root word of that, and in means the opposite of that. So we're talking about something that's not equal. There's an imbalance there. But to totally confuse you, of course, when you have an inequality, it could still be equal, right? Like less than or equal to. You remember this. Okay. So here, this is the definition of a linear inequality. A linear inequality in one variable looks like this. I can write it like this. Right in the middle of the screen, I've got ax plus b is less than 0. Ax plus b is greater than 0. Or maybe less than or equal to 0, or greater than or equal to 0. The a and the b, those are just numbers. They're just real numbers. And that's what this says right here. I'll circle up for you. A, comma, b, and it looks like it has a stretched out e. That means is an element of, is an element. There I go again. Element of, as in it's a member of that set. That's what it's trying to say. Of the real numbers, and a can't be 0. If a was 0, then you wouldn't have a variable, because 0 times x would just disappear, then that would just be silly. Okay, so x really in there is the only thing that's a variable. A and b, they're just numbers. Okay, right. And so any value that makes your inequality a true statement is called a solution. How many of these do you have? Well, sometimes you have more than one. Whenever you solve an equation, you're expected to get like 1, like x equals 5, and you're done. But here, for an inequality, it's anything that makes your inequality true. So maybe the number 5 makes your inequality true, but maybe so does 4. So how many solutions would you expect for a linear inequality? Well, you sometimes have an infinite number of solutions, okay? And so how do you represent an infinite number of solutions visually? We usually do it with a graph. And these kind of graphs are very easy because they're just on a number line. Hey, Yeah, we could do that. Take a look. So graph each of the following inequalities on a number line. X is greater than -3. X is greater than -3, right? Because it's alligator mouth is munching the X. Okay, so I just got to put a number line here. And whenever you're doing that, I don't care about like little tiny details on this number line. You just give me like a 0. Give me where the -3 is, something like this. And now I need to graph the inequality on here. So X is greater than -3. Can it be equal to -3? No, it can't. So we indicate that with an open circle. And then which way is bigger than -3? That's to the right. Everything going to the right is bigger than -3. So I would probably graph it something like that. Okay, so whenever I have an less than or a greater than sign, I'm going to have an open circle. So look at number 2. Number 2 says X is less than or equal to 0. Well, here, whenever I draw my little number line, all I need is the 0. That's it. I don't need anything else. And now, which way is less than that? That's going to be to the left-hand side. And since this can be equal to, it's like I have a dot on a graph. Boop. I get to color that thing in. Stop doing that. And then color it to the left there. Ha, 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 there. That looks great. That's fantastic. And so sometimes teachers go, or maybe even you do, like on your own noticing a pattern. Oh, whenever I graph number 1 up here, X is less than -3, I just follow that inequality sign and I point it in the same direction. And number 2 is go in the same direction. And that's fine as long as you realize that that as a shortcut only works if your variable is on the left side. If you were to switch that thing around, then it doesn't make sense anymore. So just keep that in mind. So whenever you're graphing these things, these inequalities, if you just have straight up less than or straight up greater than, open circle. And then if it's equal to it, then you get closed or colored in circles. Okay. Next, let's talk about compound inequalities. Think in English, a compound sentence. A compound sentence was you take 2 sentences and you cram them together with a conjunction. I think that's what it's called. Like a comma and an and, or a comma and an or. You do exactly the same thing with compound inequalities, but you don't need a comma. But you do need either an and or an or. There's no buts, just ands or ors. Well, there might be buts. Let's not talk about buts. Oh, anyway, so and inequalities are or inequalities. And you probably have seen an and inequality last year in geometry. Triangle inequality, this is usually where you see it, like whenever you have 2 sides of a triangle and you add it up, it has to be greater than the third side. And so a question is always like, I give you 2 sides of a triangle, between what 2 numbers does the third side have to be? Because that's usually what they ask in geometry. I know because I used to teach it. So let's look at these 2 kinds. Let's look at the and inequality first. And inequality is always written as you see it, as it looks like one complete statement, but really when you break this up, it's 2. Take a look. It is X is greater than -1 and X is less than 2. That's the 2 pieces of information. If you were to break this thing up, look at where the X is. The X is less than 2. That part is obvious from that part. But look at the X is greater than -1. If you read it from the X's point of view, you can see X is on the bigger side and the -1 on the smaller side. Okay. When I write and inequalities, I always cram them together. Also, look at the kind of inequality signs that they are. In that statement, in the single statement, the one that's right here at the top, is only ever less than or equal to signs. You never put greater than signs in there, which means this always goes from small to big. Always from small to big. Here's what the graph looks like. It is always a segment. It's in between 2 numbers, in between a -1 and a +2, everything in between there. That's an and inequality. The second kind is an or inequality. So here these 2 they're completely separate. We never cram them together like we do the ands. Just keep them separate. Either x is less than -1 or x is greater than 2. Okay? So on a graph on this one, it's two rays, and they're pointing in opposite direction. So you can see this from the picture. Maybe x is less than -1. It's got an open circle around it. Or maybe x is greater than 2. And it's going to the right. Also an open circle. Okay, so we're going to be working with these kind of inequalities, compound inequalities throughout here. Graph the compound inequality. -1 is less than x is less than 2. Okay, this should be a piece of cake. We know that this is an and inequality. So I'm going to put that and inequality. And those things look like segments. So I'm going to be drawing something like this. So let's draw our number line. And then number 0 and a -1. And just kind of try to space this so visually it kind of is proportional. Doesn't have to be perfect or whatever. Now, these two numbers, -1 and 2, do they get open circles? Closed circles. They're open because there's no equal to sign in it. And then it's everything, it's -1 is less than x is less than 2. What I'm trying to say is everything in between -1 and 2. Okay. And here's the reason why that graph is the way it is. Really, this is the graph of x is less than 2. So whenever you graph x is less than 2, you'd go open circle and you would graph it to the left. Okay? And then the other part of this is x is greater than -1. So x is greater than -1 would start at -1 and it would move to the right like this. And you want to know, where do both of these things take place? It's an and where they both take place is that segment part right in the middle. Okay, on number 2, I've got an or inequality. So I'm going to have rays that are going in opposite directions. So just draw myself a number line, a 0 here. Let's put a +1, and then I need a -2. The -2 is equal to, so it gets a closed mark, and then it's less than. X is less than or equal to that, so it goes to the left. Or x is greater than 1. So open circle around that, color it in, there we go to the right. So some notes on that, or some indications, is compound inequalities, ands, they're always going to look like segments. And ors, they're always going to look like rays going in opposite directions. Okay? Okay. So here are a few of them for you to try all by yourself. So graph some of these and see what you come up with, pause it, and then unpause it and see if you got them right.